Alright, so here's our beginning for the chromic acid oxidation of cyclohexanol. In the Erlenmeyer, I already have some cold sulfuric acid. I've already measured out the cyclohexanol, the sodium dichromate dihydrate, and some water. So the procedure calls to pour the cyclohexanol in the sulfuric acid, mix well, and then I'm going to go ahead and throw a little bit of ice around it to keep temperature down. Sulfuric acid, by the way, has a tremendous heat of solvation. So anytime you dilute it into anything or with anything, it wants to get hot. So there's that. Now I'm going to put the water in the dichromate. And the dichromate, when mixed with the sulfuric acid, makes chromic acid. And that's what's actually going to be our oxidizing agent. Now dichromate, on the hand, instead of sulfuric, it actually is an endothermic. So right now it's getting colder, and I'm probably going to need to warm it up or at least break up the pieces that are in there. But once I've got this dissolved, I'm going to pour it into my separatory funnel. If I don't get it absolutely all to dissolve, I'll decant and put another milliliter or two of water and then add that. But let me go ahead and get that done while you wait. Alright, as you can see, we've gotten our dichromate solution into the separatory funnel, and I've popped a thermometer into my sulfuric acid cyclohexanol mixture, and it's down just over 10 degrees C, so it's plenty cool enough for us to start our addition of dichromate. And here again, this is an exothermic reaction, and I definitely want to keep it under control. Okay. So you can see as the dichromate hits the sulfuric acid and turns into chromic acid, that right away the color is changing. As the chromium then changes its oxidation state, it reduces and the oxidation then occurs. Okay. So just that little bit brought my temperature up to about 15. So here again, if I'm very good with my stopcock work, I can have it just set to drip, okay, swirling all the while. So we're going to let this drip in, and then we'll be back. Okay, we finally have all the dichromate added to our Erlenmeyer, and notice that it went from a clear solution with adding orange to that kind of icky green to a nice pretty blue, and now it's completely brown in color. You can see. But we're going to then move this into the round bottom flask so that we can distill the product. So that's almost all of it, but notice that there's still a little bit more remaining, which is why your instructions say to use 2 or 3 15 mils rinses for your Erlenmeyer, so we can make sure and get almost absolutely everything over. This is what it means by quantitatively transfer. The entire quantity, hopefully, of reaction mixture ends up in the round bottom. This also dilutes the reaction mixture, and I forgot the methanol, which is okay as long as I've added it before I start the distillation. So let me go get some methanol. The methanol is going to reduce excess dichromate and allow us to separate the product more easily. Alright, already had the 2 mils of methanol actually measured out. Forgot where I put it. But in it goes. Give it a nice swirl. Notice the color changed a little bit. Here again, that should be plenty to reduce any excess dichromate. Now we're just going to finish setting up the distillation and start our heating mantle. Okay, I think we're ready. We're going to start this heating. I've decided on a 25 ml round bottom as my receiving flask because we started with about 20 mils or so of alcohol, and the density shouldn't change that much, so we should hopefully get about 20 mils of product. That might overfill a 25 milliliter round bottom, but we definitely don't want to go as high as 100. So here again, because it's aqueous, we can start it pretty high, and we'll see how it goes. So the distillation of the cyclohexanone is proceeding. I've taken the round bottom out of the ice bath so you can see that I am indeed getting 2 layers. Every so often I'll take the round bottom off and use a small test tube to see if I really am still getting 2 layers, as there's plenty of water that will still distill and so I will just take more time if I don't shut it down once the product is done. Distillation is done. I shut the heat off. I took the source flask off, and now I'm going to take my receiving flask, which has, as you can see, 2 layers in it, and I'm going to put in some sodium chloride. This is just to make sure that the aqueous layer is as polar as we can get it, so it really drives the organic layer out, and vice versa compared to each other. Then I'm going to decant this into a separatory funnel, isolate the organic layer, and then dry it. Alright, so our cyclohexanone and water has been sitting. Here again, I'm going to decant, which means pouring the liquid out, leaving the solid behind, hopefully. The aqueous layer should be on the bottom. No washing this time. We're simply using the separatory funnel to separate out the 2 layers because they azeotrope together. Alright, into another beaker with drying agent, and then we'll see what we got.